Hello, and welcome to this brief demonstration of the Lavastorm Analytics Engine. Today we are going to be talking about the advantages of the Lavastorm Analytics Engine over traditional databases and spreadsheets, especially when you are solving an analytic problem. The Lavastorm Analytics Engine, in fact, is specifically designed for analytics, unlike traditional spreadsheets and databases, which are designed more for simple queries and or data storage. The Lavastorm Analytics Engine solves the problems that today's business analyst faces when dealing with more data, more changing data, more speed requirements or requirement to respond more quickly, and the fact that there are more people asking questions and wanting to use analytics to drive their decision making. In a comparison of Lavastorm Analytics Engine to traditional spreadsheets and databases, there are a couple of key advantages for the Lavastorm Analytics Engine. Specifically, the Analytics Engine, because it is designed for analytics, has a number of pre-built analytic logic or control pieces that can be used to assemble an analytic application much more quickly than you could within say a SQL environment, for instance. In fact, people have tested the Lavastorm Analytics Engine versus SQL coding and found that it's 90% faster than traditional SQL coding to develop an analytic application. The next point is that the model itself, because it is a visual model, provides some significant advantages. The demonstration will highlight some of those advantages, but because it is visual, it does reduce the scripting required to create the application. The visual model can actually expose additional information about the data that you're working with, and that could lead to new insights or new questions that you want to ask and answer. And the model actually captures the business logic or analytic logic that the business is using. And by capturing it, it makes it reusable, so standardizes various processes, maybe some manual manipulation of Excel processes. And it allows you to share that logic for other people in your organization or your company, etc. And finally, because it is a model, it does allow you to get a quick handle on the entire scope of your analytic and also pinpoint areas where you might want to explore further and either delve deeper into the existing model or even change the model. The last point here about advantages is about the speed and flexibility that it offers for discovery, or what you might call ad hoc analytics. Discovery is typically a process of asking a question, getting an answer, and basing another question on that answer. So there's a question after question after question kind of process, typically to identify a root cause for a particular issue. That often means that you may need to change the model as new questions arise, or you might need to incorporate new data sources or simply ask new questions of the existing data sources. And so the Lavastorm Analytics Engine has a way of combining data that's much faster than traditional databases and does not have the overhead of creating table structures and or overarching schemas that are required to describe the entire data set. So there's significant speed advantages for the Lavastorm Analytics Engine in this regard. So let's take a look at a typical application. Now the situation here is that this application was developed for a communications organization that was investigating the root cause of some additional support issues that they were dealing with. So they had just launched a new service, an IPTV service, and were measuring the profitability of that service. But their profitability was not where they wanted it to be because they had an unusually high number of customer service issues that required them to send people on site to address those issues. And obviously that hurt their profitability. So what they were looking for is a way to identify the root cause of those issues so that they could eliminate them for good and improve their profitability. In this case, because it is a customer service issue and it did involve a service that had to be installed and turned on, They wanted to include various types of data to get to that root cause. They felt they had to. So first of all, you'll notice this analytic application involves a number of different data sources, from databases, extracts from different operating systems, even text files with various reference information, in this case coming from various order systems throughout the company, so there's 6 data sources there. There's also additional information that comes from installs. So there's a scheduling system that sets up the installations when they're supposed to happen. In this case, this company uses a third party to actually do the installations, and so it goes to an outside organization. That organization provides some timesheet data to describe what happened on each installation, and that comes from a totally different system. So there's an additional 2 data sources right there. And then finally, they combine that with information from their call center, where the trouble tickets are usually raised as issues. And so this comes from their call center. It's called voice tickets. So what you'll see is that, first of all, the Lavastorm Analytics Engine is able to combine different data sources. And again, this happens very quickly. You won't see that here, but we can do that in days or hours as opposed to weeks or even months or years. And these sources of information are very distinct. So some are coming from different departments within the company, but others are coming from, even this installation information is coming from outside the company. Very different systems, very different sources. We can add these sources in an incremental fashion, so we don't have to develop an overarching model of how all that data connects together. We can just join data on the fly as we do our analytics. So that's one of the key advantages of bringing all these different data sources together. So I want to show you what that's like. If we look into the trouble tickets, you'll also see, in addition to the fact that we're bringing in information from a different source here, in this case the call center, we have built up our analytic logic here. So I mentioned that the nodes or business controls that we offer, this is one, this is another one, they include some really powerful analytic capabilities. So in this case, we are actually bringing in data from a directory, and in this case we're looking for a pattern of file naming, and as files are put into that directory, this analytic application will find them. So and the model itself is telling us, because there's a 2 here, that we've actually found 2 data sources that meet that criteria. So there's 2 files here, and as you see, if I double click on various parts of the analytic application, I get additional information. But without clicking on anything, I get information that I'm having 2 files pop into that directory that are relevant, that are coming from my call center. Those are being converted into a single CSV file with 125,000 plus records. And then there's various data manipulations that take place on that file or on those records. But even just this node here, which is bringing in the data, something that happens automatically. So it's got that pre-built logic to help my analytic. If I were using SQL, I might have to do something outside my analytic application to combine these various data files into a single file before I can even upload them into my system. Other analytic controls that we offer are the data analyzer actually reveals a great deal about the data itself. So once I have that CSV data coming in, 100,000 plus records, this is giving me information about the various fields that are in there, what types, whether they're strings, integers, etc., the length of various fields, 10 digits, 3 digits, etc. It also shows me how many nulls there are and where the nulls are so that I can eliminate them. A lot of information. This is very valuable if I want to look at the data and understand where I am from a data quality perspective, and it may indicate things that I want to fix along the way. Another example here is trim fields. This is taking out zeros that might be added to fields as part of their operating systems. This particular filter is actually taking ticket numbers In some systems, it might not be able to support dashes, so it's converting dashes to spaces, etc. So a lot of different types of analytic controls can be strung together here to manipulate the data in any way I see fit. This is, and another thing that's happening here is that I'm also, in addition to processing the data through this flow, I'm also bringing in additional data and enriching that data with data that's coming from these timesheets that the installers are filling out. So if I open that, I can drill down at any time to see the actual data. You'll see that what I'm bringing in here is actually very detailed information, notations that are coming from the installers about specifically what happened during the installation. So it's very, a lot of times this is the most important data because it adds a lot of descriptive information that may not be shown in the standard forms. Again, that can go through a data analyzer, and then it's just joined in using a single key so that it's all unified here together. One of the so right off the bat, you're seeing the flow that the model represents. It gives me a step-by-step guide for what's happening to the data. I can pull off at any point here and add different nodes. So if I wanted to do an additional filter, for instance, off of that information, I could do that. I could pull it off any location, so I can kind of change the location simply by pulling wires around and changing my model in that way. So one advantage of the Lavastorm analytics engine, though, is that changes to the model are very fast. And if my business conditions change, so for instance, if I add a new channel where I can accept trouble ticket information from, so maybe I add a channel where I can accept that information over the web, then I can simply copy and paste and duplicate that logic very quickly and kind of connect it up through the wires to make sure that that works. So I'm setting my pattern, so I'm looking for files with a .NET introductory characters. I want to do the same thing, bring in my CSV, bring it into a CSV file, look at the data, trim those fields that I mentioned. When I have a model like this that's already preset, all I have to do is rerun or run the new parts to the model in order to change the model. So it's bringing in those files. In this case, it found 3 files with that pattern, and you'll see that they all have a .NET predecessor to their file name. One thing I see here is that this is giving me information about that data, so it's giving me a red X because it's telling me, as the error shows here, that it got 10 columns, but it was expecting only 9 columns in that data. And that's probably a very common thing. I'm dealing with CSV files here, so there might be a misplaced comma. If I want to investigate that, I can certainly do that. One of the things that again is sort of pre-baked into the analytic controls that we offer is that if I want to flag those errors, I can simply add a new pin on my control and rerun that again, and all the errors will be automatically routed. So you see it was successfully run there, and they'll be routed to the second pin that I just added. So I'm finding out that there are 5 records with those errors and 162K records run through successfully. But if I want to investigate these 5 errors, again, if I open it up, I can drill down to the data. It tells me for each one of these same error, expected I got 10 columns, but expected only 9. And it even gives me the actual record string here, so I can see what the error might have been. In this case, I'm familiar with the data and how it should look, so I can see that between the date and the time, there's actually a comma there. There's really not supposed to be one there. So that's the source of my issues. In this case, one of the things that I can do in addition to doing the analytic logic that we're seeing here, I could actually decide that I want to correct these issues. Now, it's not a big deal because I only have 5 records here that are a mistake. But through the library of analytic controls that I have the ability to add any kind of logic here that I want to fix that error or sort of flag it. So for instance, if I have nodes here for doing things like acquiring data, filtering data, statistical information, visualizations, publishing. So in this case, I might want to send an email to somebody to tell them that there are records here that are have a data quality issue. I may also want to, or instead, I may want to filter those issues and so or correct them on the fly right here. And I can add that filter logic. I'm not going to add that filter logic here, but just suffice it to say that I can add some logic here to correct the correct the comma issue. And I can add that logic here. I may even want to add a tolerance, and in that case, I want to add a separate node here, which can look at. I can set this one up. This is my my check. This could be my tolerance on errors, and has, again, I'm not writing any scripts here. I'm just configuring nodes. So maximum record count, I can set that up to be 4, and I can set up an I/O pin. That's going to be errors. And so that's looking for, if I have more than 4 errors that are out of spec, then I can do something. And what I might want to do, I decide, I'm going to try to fix it here, and I might want to send an email to somebody. So just by reconnecting the flow here, I'm dramatically changing the logic. It's much faster than working with SQL code, much easier to tell where I am within the code to do that. And I have this pre-built logic that gives me the power to do things that could be very tricky if I were writing SQL code and using a traditional database. Now, to complete this adding of a new data source, which is not a trivial task in many cases, I can simply bring these together. I'll use what's called a cat node to concatenate the data. Again, reconnect the logic here. In this case, again, I'm not doing scripting of any sort, but I do have to configure this one. It's all pre-built logic here that's easy to configure. And then to simply complete this, I just need to rerun the nodes again that have been affected by the change. And so I don't have to rerun the whole model to get my new result. So again, very, very quick to update the data, very quick to modify, and some powerful modules in the form of these controls that help me develop the analytic application that I want. And we're going to pop up back again to the top level here. I'll just show you one other example of modifying the logic. Again, in this case, we're doing some pretty detailed things around the data. And if you're working with Excel spreadsheets on a monthly basis, say, and perhaps you're bringing together different financial reports, you might have to go through multiple steps of Excel manipulations to get these files coming in from different sources to match up. And you can automate all of that in the form of one of these kind of flows. So in this case, we're taking in data from these timesheets that are coming from the third party. We're adding work codes to them. So this might be a series of function codes that are added under certain conditions. We're also looking for telephone numbers and removing the telephone numbers that don't have 10 digits, so we know that they're bad telephone numbers. We're looking in this case, because we're investigating the issues with this one service that was added, we're looking for a particular product code that's associated with that product and filtering out all the rest. So again, the model's telling me there's 125 that are not relevant, 1,261 that are relevant. And then I split it up. So in my past analyses, I said, you know what, for the installations versus repairs, I want to look at them differently. So for installations, I want to do some additional calculations. Let me look at the the time that was spent on a lunch break, the time that was spent facing a customer, and I even want to add a geographic filter here based on area code so that I can cut the data by geography. So that might be the first approach that I took, is to look more in depth at installations. But if I wanted to change the logic, again, it's very simple to do that here, and I don't have to deal with any sort of tables or temporary tables or multiple queries to do that. It really is as simple as dragging and dropping the logic. So if I want to apply the same logic to both installations and repairs, I simply reconnect the flow here. So I just want these graphs going in there. This one will now feed the filter node, and then I can simply delete this one and reconnect here. And now I've moved that split, so that logic is all being applied to every record and then being split into installations and repairs. So I've completely changed my logic really in the matter of seconds, whereas it might have taken me quite a while to figure out the right place to go and even make that change if I had a pretty detailed SQL script that I was dealing with. Again, I just recalculate again and then I'm off and running. So now what we've seen is I've brought in a lot of data, prepped it in a bunch of different ways, automated some of that prep work. So when I want to run this on a continuous basis or a monthly basis, I just put new data into those directories and it just gets pulled in and processed in a consistent way. Now if I want to investigate the root cause issue that I'm investigating, I would like to dig into a little bit of some, perform some analytic queries on that. We don't have a query interface that's similar to spreadsheets or databases. We have a very different approach. But if I look at, in this case, I'm going to look at the trouble ticket information. So what you'll see here is it's a completely flexible system. I can ask various queries simply by creating the logic to get the result at the end. And so in this case, I started my analysis by looking at chronic trouble. So I took in the trouble tickets, I looked at it by the customer incident rate, I filtered it down, only looking at trouble tickets that were created more than twice. So I had multiple complaints on those particular issues. That didn't yield any sort of spectacular or obvious root cause issues. So I went off and I did another path to investigate. I brought in some order data, combined it with the trouble ticket information, simply joined it together, matching on telephone number, and then filtered it down to the orders that were already completed here, and ended up again looking at chronic troublers. Again, everywhere along the model here I can get the detailed records, and so looking at that I get a little bit of variety here. One type ended up with 11 issues versus 10 versus 7, but nothing jumps out at me as a real obvious root cause. So I can continue my analysis simply by pulling data off of various points. It's real easy to find out where I want to explore more and adding a new path to the analysis. So after I looked at chronic trouble and I didn't find anything in particular, I started to look at various trouble periods after the installation. So I simply pulled off the data of the trouble tickets and order details joined up, but after installation pulled it off and filtered again, adding in my installed duration data. And here I thought maybe some of my problems are either early on after an installation or they happen long term. And so I looked at within 7 days of installation and after 30 days. I also have another pin here, 7 to 30 days, but I didn't do anything with that yet. But each of these other two, I looked at joining that data together with the duration data, and then looking at it by the technician that was involved. So in this case, when I looked at the technician data, again, I didn't see a big spread. I got 10 issues from one technician, 8 by the next. Many of them are in that range, so there's nothing obvious there about a root cause. But if I want to change my logic again and investigate a new path, I can do similar stuff to what I showed earlier. So I might want to apply the same logic to this other period. Now it might be relevant for me to do the 7 to 30 days. So let me just make sure that's wired up here. I copied that logic and reconnected things here. And again, I just simply have to run this new logic to get the results. And I'm pulling off, just purely from the model, I can see exactly where to pull off the information to do that kind of path. Again, it all comes down into data that I can look specifically at the actual results. And again, nothing really jumping out at me there in terms of root cause, because the incidents per technician, even in that other period, are not bad. So again, I might explore another path then, and in this case, I decide it was probably worthwhile to look at the equipment type. I've kind of exhausted chronic trouble and by technician. So I pull off from another point in the model some information on the trouble tickets and order details joined up, and then to that I want to join some information from the installer forms, the ones that happen out in the field by the actual installers. And I do some additional logic here to zero down on only the equipment that's relevant for this particular new service. A couple of other manipulations here just to filter down to the top equipment types, join it together, and then I can present various histograms based on that information. Ultimately, I get to a calculation of the percentage of trouble tickets by equipment type. If I look at that, I start to see here, this is percentage, that actually there's a really high percentage of issues associated with equipment type 4. So I start to get here, this is really my aha moment that could be the root cause of my issues there. So when I find a root cause like that, and again it's totally flexible how I build that logic. I could keep exploring paths, but I think this one's could be the one. So I can take advantage of this by actually adding a chart that I could share with people within my organization. So let me add a bar chart here, and I can just configure this. So trouble tickets by equipment type. And I'm just going to configure this to the x-axis, the y-axis. Again, it's pre-configured. It's really not difficult for me to do that. And then I can simply run that again, this new part of the logic. So here I've got my aha moment, but I want to create a chart that I can share with people. The output of this particular node is a visualization that'll help show to the people I work with and to other people within the organization that I might have be onto something here, and it helps me communicate. So really powerful visualizations that I can add again to help with the collaboration. Finally, when I do get those results, one of the really useful things that I can do with the Lavastorm Analytics Engine, and one of the important points about it, is that it does coexist with my current infrastructure. So I might have been pulling information from an Access database here, but the point is that Access is not as powerful for analytics. It's not designed to create this kind of complex logic that you see buried here. So I've taken the data out of Access. I may, at the end of all of this, want to put it back into Access, because that's where I store my information, and I want to store those results. So I have the ability to publish back into the databases and create a closed loop. So in this case, I want to push that information back on what I found about trouble tickets by equipment type, and I can create those results and stuff them back into Access. So again, I'm just configuring this node. and again just running the partial installation. So that ran successfully. Now if I go back into Access, I should see the results table that I just created here push back into Access. And here's the table that I push back into Access, and you see all that same data that I developed as part of my analytic is here now, and I've created a closed loop for my entire system. So what you've seen here in this demonstration is a few of the key points regarding the Lavastorm analytics engine. And just to reiterate those, what you've seen is that there's significant power in the pre-built analytic logic and controls that are part of the Lavastorm analytics engine. You've also seen that the visual model, as opposed to working with SQL, provides you a really easy way to control and get your arms around an analytic challenge. There's very little scripting that's involved, significantly less than what you'd have to do if you were working directly within a database and using SQL or some other programming language. The model itself can expose a lot of information, including some very valuable information about data quality and steps along the way about how that data is manipulated. So that's really helpful for getting my analytic application right. The model itself not only captures and executes that logic, which is very valuable if you're running an analytic application on a periodic basis, but also helps for sharing that logic. So even some of these standard flows that you saw me create there, I can create a master node that can be shared across applications, and so it makes me and my team even more productive when I'm developing analytic applications using the Lavastorm analytics engine. And finally, I can pinpoint any point within that model to either pull off additional information to do a new analytic question, or to change the model to adapt to any changes. The last major point here is about that discovery and ad hoc analytics. And so you see some of the speed and flexibility of just working with this visual model for changing the model, for investigating different paths on my way to uncovering a root cause, and in integrating very different data. You didn't see any table manipulation, for instance. So we eliminate a lot of the overhead that's associated with pre-planning and table structure, and making sure that you have an overarching schema to describe that data model. So I hope you enjoyed this presentation of the Lavastorm Analytics Engine, and I hope you appreciate the power and flexibility that the Lavastorm Analytics Engine delivers. Thank you very much.